introduction into the interface of 3ds Max. Then we'll take a geometry from Rhino and actually import that into 3ds Max. And I'll show you some of the things you have to kind of look for, and then some of the things, like kind of little tricks that you need to do in order to kind of streamline that process. We will then hopefully, depending on how much time we have, introduce some lights, cover basic render settings from an exterior point of view, and then on Thursday we will cover interior renderings and advanced lighting and material techniques. Okay, so if there's any questions, if it's kind of an immediate question, go ahead, raise your hand, and I'll try and call on you. If it's something you can reserve to the end, we can do that as well. So I have already kind of gone through the process of making all of these files in separate. That way I know they work, but also so that we can see a kind of final product versus the one that we're actually working on. And so the first thing I'm going to do is I quickly, a couple days ago, created a little pavilion, which we'll use as our base for this rendering tutorial. So it's very simple. It's kind of a gridded space. It has a few kind of walls or partitions, some smaller spaces, and then it has this kind of skylight with a curved element. And basically I just made this so that you could start to see various different geometries, and we could really work with different lighting situations. So this tutorial isn't going to cover how do you model this in Rhino. Those are previous tutorials. All we're going to show is how do you export this model from Rhinoceros into 3ds Max. I learned that Professor Vesely has Rhino 4, and I built this model in Rhino 5, so we're only able to see it right now. But I'll show you the process of exporting it, and then I've already saved the exported model. Essentially what you're going to do is we want to just take these geometries as they are, and we want to put them into 3ds Max. The difference is that 3ds Max really only works with meshes and NURBs. We don't have any NURBs here. So what we're going to do is we have to translate this model, and we have to convert it into a series of meshes, which will then import into 3ds Max. There's two ways you can do that. If you have very complex forms that are curvilinear, and more specifically, you can actually convert them into a mesh within Rhino and then export the mesh. That gives you a little bit more control over how the mesh is made. So that's like, you know, if I just type in mesh, we'll try it again, hold on. I should have saved this down to Rhino 4. It's my mistake. I won't actually type in the command, we'll just... So if I select an object, I can type in the command mesh, and that will bring up a series of options that will allow me to convert this solid geometry into a mesh. You only really need to do that, like I said, if you have complex geometries. Everything in here is a relatively simple geometry, so we're going to let the export process do that for us. So the way that happens is you select the objects that you want to export. That can be all or some of the objects that you actually have in the model. We will go to File, and we will say Export Selected. Now, as this is the trial version of Rhino 5, it's not letting me do that, but I already have the model saved. So you would say Export Selected, and you would export it as an OBJ file, .obj. It's an object file. And an object file is an automatically meshed geometry. So it will automatically convert the geometries you have in the model into a mesh, which can then be imported into 3ds Max. And so that file looks a little something like this. I've named it paviliontutorial.obj. There's a few settings in there that you need to be aware of. OBJ files are usually reserved for animations, and for some reason the standards in animation are a little different than the standards in other modeling programs. And so in some cases it'll convert the z-axis in your Rhino model to a y-axis in your OBJ file. There's a little checkbox, just make sure that is unselected. It'll say convert XY to YZ or something like that, just make sure that that is unselected. If you do have that selected, obviously your model will come in sideways in your 3ds Max, and that should be a cue that you've done it the wrong way or that you left that box checked. So here's our Pavilion tutorial. I'm going to close out of Rhino just so we can save on some computing power. And we have the OBJ file. Now, what I'm going to do now is we're going to open up 3ds Max. We're going to cover the interface, and then we'll import that OBJ file into it. So I'm going to open up 3ds Max Design 2014, which is free software to students, by the way. You can download it. All you need is an educational email address. It's an Autodesk software. Autodesk, while it's loading, Autodesk also provides render farms free to students. I think it's called Autodesk 360. I think it's something like that. And basically you can sign up and you can send your rendering calculations to their own personal render farms, which drastically speeds up computing, which means you can be working on your laptop on something else while your rendering is rendering in an Autodesk server. So, showing up okay? Good. This is how 3ds Max will open for you. In some cases it might open with a 4-window like this, and we'll cover what these buttons are. But this is the kind of default. And like most remodeling programs, you have at the top, you have a whole series of drop-down menus, which basically anything you can do with any of the icons or shortcuts, you can also do in these drop-down menus. There's a large amount of redundancy in a lot of these modeling programs. So it ranges from the relatively standard opening new files, saves, imports and exports, so on and so forth, all the way through editing, which this can be editing objects, mostly edits objects. You have a whole series of tools. I'm not going to go through each tool and explain what each one is. Instead, what I'll do is I'll explain the tools as we use them, because there's way more tools and functions you can do in this program than we would have time for in 2 days. And I don't, to be honest, I don't know them all. You have controls of groups, you have controls of views, create not only geometries, but you can create lights, cameras, systems and helpers, modifiers, animations, so on and so forth. One thing about 3ds Max is 3ds Max is a modeling system based on modification of primitives. So you create geometries and then you modify those geometries into what you want. You don't usually create complex forms kind of immediately. It starts as a simple form and then is modified. And if you're really interested in modeling, you'll have to kind of do that research on your own. We're just going to cover rendering. Underneath that, you have a series of icons, which are kind of, we're missing a few. Let's see if I can. You may have more icons. I think it's probably based off the resolution of the screen. It's cutting some of them off. But I'll show you I'll use shortcut keys for those. But I'll tell you what they are. So here you can kind of select and link different objects together. There's the selection tool right here, which basically, as I click on objects in the model, that will select those objects. There's also select by name. Some of your models can get really complex and you have a large number of objects. So if you just want to select a light or something like that, you can actually limit, and I'll show you this later, you can limit what shows up on the select by name, and that can be a very useful way of selecting objects. You can select rectangular selections, and then there's move and rotate and scale. This moves, rotates, and scales different geometries in the model. You have a whole series of snaps, which I don't tend to use. The only snap I really use is the snap angle, because again, we're not going to be modeling too much in here. But this is just like your normal endpoint, midpoint, so on and so forth. And then you have over here mirror, and then a series of management layers. And then what you can't see, which might show up on your default screen, is things like render settings, and then the actual render button. And so those might show up if you have a higher resolution screen. Underneath that, you have what's probably what we'll use the most, and this is similar to how you can create objects up here. It's a panel that allows you to create objects, modify them, set them up as a series of definitions of hierarchy, motion, so that relates to animation and so on and so forth. We're going to be only using the create and modify tool primarily. But under here you can create geometries, you can create lights, cameras, and then at the end you can create systems. And I'll show you the system we'll be using once we import our model into that. Next to that is the modifier list. So if you ever want to change a particular quality or an element of an object, you're almost always going to do that through the modifier list on the right. So you'll select the object, you'll make sure that the modify tab is open, and you'll see as we import the model, there'll be a whole series of things you can change or modify about that object. Okay? The bottom right are navigation icons. So these help us, we use these to actually navigate around the model. So you can rotate. There's a whole series, if you left click and hold, there's a whole series of, you can rotate about an object, rotate about the whole model, or rotate about a world point. I always tend to leave this at rotate about the object. Lets me have a little control, so if I select an object, that will become the center of my rotation. You have pan, we can change the field of view, we can zoom in and out, and then we can zoom all or zoom extents. And then at the bottom right is the maximize viewport toggle. So in Rhinoceros, where you double click on perspective or whatever, here you have to do in the bottom right, and that opens up your top, left, right, whatever perspective views. So we'll be switching in and out of that. Basically, the perspective allows us to see what the scene is as we're looking at it, and the other ones allow us to move cameras and lights, things like that. To the left of that bar is your animation bar. We're not gonna really talk about that today. Since we only have 2 tutorials, I'm probably not gonna be able to get to animation at all. But at the bottom of this, you can see there's a whole time frame. Each one of these represents a single frame in an animation. So that's what that is, the bottom. So that kind of covers the basic interface. And so what we're going to do now is we're going to import that OBJ file that we exported from Rhinoceros, and we'll see what happens. So we're going to go to File, Import. We're going to import a non-native file format. I'm going to open up my OBJ file, Pavilion Tutorial, and we'll open that. And you can see we have this another interface. And what's happening is 3ds Max is importing every single object as a separate object. There is no way around that when you convert this to an OBJ file. So the layers that you have, for instance, in Rhinoceros are not going to carry over into your 3ds Max file. That's okay. There are ways to kind of work around that. And basically what it means is that you have to export different layers or different objects if you want them to be grouped. So you'd import the object and then you would group them together so that they're selectable. It's not really a big problem because you have to think about the way you built the Rhinoceros model may not be how you need the model to be in 3ds Max. As you bring this into 3ds Max, you're only concerned with materials, right? You're not concerned with what the object actually is. So that you may have a layer that says columns, but if the columns are one material, same material as the walls or something like that, you don't need to import those as different groups. Is that clear? Relatively? Okay. So it's going to bring in an entire set of objects. Each one of these objects is a modeled object in Rhinoceros. And right up here you can see flip ZY axis. We're going to unselect that. Okay? This is that whole converting from an animation, which for some reason the standards flip the Z axis into the Y axis. Just make sure that's unselected. And we're going to import the model. And so we can see now each object is selectable. And it's a mesh, right? Oops, I'm in Rhino mode. I guess we should cover that too. So each one is a mesh. So it's no longer defined in the same way as it was defined in Rhino. You can also pan, just a note, if you hold down the middle mouse wheel button, that will pan. And if you hold Alt at the same time, that will rotate or orbit. Alternatively, you can do all of that with these tools down here. And zoom in and out is with the mouse wheel as well. So you can see we have our pavilion. and all the materials are the same. In some cases, for instance, I might have 2015, I don't know. They'll actually apply a different material to every single object. All you have to do is select that object, and when I show you how to apply materials, you can just apply a very basic material. So now each object is modifiable. It's a modifiable mesh, and you can see that over here when I have the Modify tab open, it's giving me a whole series of options on how to modify that object. The best thing to do, since we won't be covering modeling in this, is if you need to make a change, make the change in Rhinoceros and re-export the object. The world origin will stay the same, so you won't have to move it into place, assuming you haven't moved the original model. So what I tend to do is if I make a big change, I'll delete some objects in 3ds Max, and I will re-import those objects alone from Rhino into 3ds Max to take their place. Does that make sense? So if I wanted to change the placement of columns, I could delete the columns in this model, and I could re-import those columns from Rhino. Alternatively, I could just delete the whole model and do it again. But if you've already applied a lot of materials, that may be time consuming. So the first thing we're going to do is we are going to open up the materials palette, and we're going to just apply a very basic white material. We'll call this a clay rendering. It's a rendering without any materials at all. And the way you can do that, there is an icon up at the upper right, which isn't showing on the screen, which is your material editor. Alternatively, you can just push the letter M, and it will show up. Now, in 2012, I believe, 3ds Max came out with a new way of manipulating materials called the Slate Material Editor. And much like a definition 3D in Grasshopper, you can actually create definitions for materials. I learned it the other way. I don't have a lot of experience with this technique, so this will be the default that pops up on your window screen. We're going to convert that back to the old material editor up in modes, and that's just called the Compact Material Editor. So when I push that, it's the same thing. You can do the exact same things. It's just a different way of visualizing it, and in some cases the Slate Material Editor is a little more flexible. But for our purposes, we won't really need it. So here we have materials. They're all mental ray materials because our default renderer is mental ray, and I'll show you how to make that setting a little bit later. But what I want to do is I just want to select this whole model, and I'm going to take this default material. Yeah, this should be okay. I'm going to change it to I'm going to click on the ambient light, make it to a white, and then to apply materials, you just click the material icon, you drag it over the object, and you release. If you have multiple objects selected, it will ask you if you want to assign it to the single object that you hovered over, or do you want to apply it to the whole selection. So we're going to apply it to the whole selection. By default, the model came in and it already applied this material as the default material, so we didn't see any change. But for instance, if I were to apply this material, you'd see that it would start to map that material onto here. We don't want that material. It's a gross material. We're going to have a little more control over the materials we make, but for now, we're just focusing on applying a really just plain white matte material. So I'm going to minimize that, and so you can see our model represents that change in material. So now that we have this kind of white material mapped onto it, what we need to do in order to render something, we need to apply a light. Now, 3ds Max by default, if we go to rendering and push render, 3ds Max gives it this kind of automatic diffuse light, which is way too bright in this situation. So what we're going to do is we're going to create a daylight analog. So it's in a system. I'm going to check one thing before I do that, because I don't like this material. So maybe we'll cover this really basically, but this material appears to have some kind of glow, and that's because it's the kind of default material. But in order to change that, what we're going to do is we're going to click on this. We have the icon selected, and we're going to change this from a standard material, which is right here, to a mental ray material called Arc and Design. So before mental ray was the default renderer in 3ds Max, it was a scanline renderer with a radiosity calculation. Mental ray is far more advanced than that now, but they've left the old materials in there. But the materials we want to use, we really want to do them under mental ray because they are more compatible with the mental ray renderer. So I'm going to click Arc and Design. I'm going to say OK. And we're going to change the color to white. And we're going to, under select a template, we're going to select a matte finish that's not reflective. Okay? Now I don't have to reapply the material because I'm changing the material itself. It's automatically going to update in the model. So I'm a little more comfortable with that material, so we'll just use that. So what we need to do is we need to create a system, a light system. And the reason why it's a system is because it's not just a light. There's an actual system attached to it. So it is a light, it's a direct light and a skylight, but it's tied to the way the sun actually operates. So we're going to go to Create. Anytime we're creating something, it's always in the Create tab. And we're going to go to Systems. And under this, you can see that we have a daylight and sunlight system. I always forget which one it is. I think we'll click yes, okay. So what we want to create is a daylight system. So a daylight system includes both the sun and the skylight versus a sunlight system which only makes the sun. Does that make sense? And it's just like creating a light, except it's tied to how the sun actually moves based on your location and the time of day and year. So we'll click daylight. The first prompt that's going to come up is it says we're creating a daylight system which is based off of mental ray. And so it's asking us if we want to use MR photographic exposure control, which is the mental ray photographic exposure control. And we're going to say yes because those two, that exposure control and this daylight system are very compatible. And what I'm going to do now is I'll do it over here so you can hopefully see it. I'm going to left click and hold. And as you can see there, a compass starts to show up. You guys can see that, right? So that basically, this is the system that you're tying the light to. I'm going to release, and that's tied to north is your Y direction, east is your X direction. So when you're building your Rhino model, you can kind of do that. We can also rotate it in here, and I'll show you how to do that. And now it's saying you're creating an MR sky, which is a mental ray sky, and it recommends that we also add an MR physical sky environment map. I'm going to say yes, but afterwards I'll show you, I'm going to uncheck that because it looks kind of tacky, but I just want to show you what it looks like. We'll click yes. And the last thing I do, I'm not holding the mouse or anything, is I'm specifying a height of the actual sunlight daylight system. It doesn't really matter where you put this. I tend to try and make it so it's at least above my model, just in case. And I'll left click and it places it in the model. So now you see I rotate around, you can see that light, right? And it's tied to, if I open the Modify tab, a whole set of settings that allow me to manipulate the intensity, the location of this sunlight and this daylight system. And so you can say we have the sunlight, it's active. If we deselect this, obviously that light is off. And we have an MR sky. And we're defining its position by date, time, and location, which we can set up. And if I click the setup, it brings me into a child folder of that. And this says it's at 12 o'clock. This is military time, so if I wanted in the afternoon, I could say 1500 hours. And we'll say September 21st. And you can see, oops, you can see its position has moved relative to that time and date. And if I want to get location, we can see right now it's set on San Francisco, which is where Autodesk is headquartered, but we can also do Chicago. Champaign is in here too, so we'll do that. Right? And so now the position of that sunlight is exactly where it would be on September 21st at 1500 hours. Right? So that's why it's a system, it's not just a normal light. So now we'll try and render this again, just from our perspective view. And we'll be, oh, sorry. And you'll see that now the rendering is, it's obviously projecting shadows. You're getting indirect light, so you can see how this is kind of blue, this blue shadow. That blue shadow is a result of the blue color of the sky. which is defined by the color in the daylight settings. And if we move that light back and forth, we'll get different sunlight positions. So for now, we're just going to stick with that position, and we're going to cover render settings. So before I do that, we'll cover, let me talk about selection by name. So if I wanted to select this daylight system, which I'm about to do, I could, in my perspective view, just come over here and select it, right? But I could also go select by name, and you can see that under select by name, we have all of these objects. And I can just turn those off by not displaying geometries, and that way I can select that particular daylight system. It makes it a lot easier if you have a complex model, especially if you're using artificial lights, which are actually embedded into the model. It can be relatively hard to select them in your view. So you can just go by and select them by name. So if I select by name, and I go to the Modify tab, right? This is where I can actually control all of the sunlight and daylight systems. And since this is an MR sky, I can't actually change the color of the sky, which is why when we get later into advanced light settings, we'll separate the direct light and skylight into two different lights so that we have a little more control when we do interior renderings. But you can also alternatively change this from an MR sun to a standard sun or to a standard skylight, which allows us to, see if I can find it, skylight parameters under the Modify tab. It allows us to actually change the color of the sky. So if you don't like that blue kind of diffuse lighting in your rendering, you can convert it into a standard light, which again, we'll do this a little later, probably on Thursday when we get into interior light renderings. And you can then have much more control over the color of the sky, etc. For now, we're going to go back and change it to MR sky, MR sun, because our exposure control is based on that. And what we're going to do is we're going to open up the rendering settings. And this is probably the most robust part of the tutorial. It's basically where a lot of the manipulation kind of trial and error comes into play. And there's a little icon that, again, isn't on this due to resolution, which is over on the right, which I usually use. But you can also go through the rendering tab and go to render setup. There's also a shortcut, F10. But if I push F10 right now, it's going to stop the recording. So here we have the render setup. And what this does is it defines basically the quality, the type and quality of the rendering that you're doing. So obviously the higher quality or the higher the settings, the longer the rendering takes. And there's a variety of different ways to manipulate that. Under the Common tab, which is the default tab when it opens up, the Common tab defines things like the resolution of the image that you're going to be using. It's pixel aspect ratio. It allows us to define whether we're doing a single frame rendering or if we're doing an animation. So that's time output. You can also do a particular set of frames if you have an animation. It tells us which area we're going to render. I always do view, just because it makes whatever view is active, which is defined by this yellow band that goes around the screen. That will define which view is going to be rendered. And then output size. And this is where you can define how large of a resolution you need. So if you're going to be doing something that's going to be projected onto a computer screen, then it might be 1080 by 12 something, right? Or if it's a small animation, it might be 800 by 600. But if it's a rendering that you intend to print and make it very large, you may have to specify something along the lines of like 3000 pixels. Oops, I did not lock the aspect ratio. 3000 pixels by 2250. And that's really based off of the resolution, so 150 dpi and how many inches wide by how many inches tall. Under that, there's a series of options about what it will actually render. So you can turn off atmospherics if you have atmospheric settings, which we'll cover next on Thursday, or effects, things like that. And so you can kind of say, well, I want to render only these geometries, or I want to render only these particular settings. Advanced lighting, if you turn this off, it won't calculate diffuse lighting. It'll only do direct lighting. We're going to leave that on all the time. And then you can also do like render outputs and email notifications. So this is really handy. Like if you render something, I've heard this problem a lot of times. Students will render something on the lab computers, and then before they have time to come back and save it, someone's logged it off, or the computer crashed. What this will allow you to do is, as soon as the rendering is done, it will send you an email notification that it's done, and you can also set it to automatically save it to a predefined location. So you don't have to worry about, the rendering finishes after 3 hours, and then half an hour later your computer crashes or the power goes out and you lose the whole rendering. It'll automatically email you and save it. Very convenient. Also at the bottom is the assign renderer. Now depending on which version of 3ds Max you have, the default renderer might be NVIDIA Mental Ray. It could also be default scanline renderer. Make sure that this is kind of one of the first things you do when you check this. When you open up a file, make sure that it's set to NVIDIA Mental Ray instead of default scanline renderer. You can always save that as default if it's not the default. I think on the lab computers it's automatically at with Mental Ray, so you shouldn't have to worry about that. So that's the common tab. The next tab, really we're just going to be talking about 2 of these tabs, but briefly we'll cover the renderer tab. This tells the rendering process, so Mental Ray. This defines the quality in some cases, but it's basically the last step in the rendering, so this doesn't have to do with global illumination or diffuse light. It's just the quality of the output that you get, and you usually don't have to touch this very much. So the tab that we're going to be most talking about is global illumination. And global illumination essentially calculates diffuse bounces of light in your renderer. So it takes into consideration material reflectivity. It takes into consideration the intensity of direct lights and how many photons actually bounce off of the wall surfaces. So if we turn off, for instance, if we turn off advanced lighting and we re-render this scene, well, actually it's still doing diffuse lighting. Let's try that again. Here, final gather. We're going to turn off final gather. If we re-render this again, you'll see, and I'm actually going to change the quality of, anytime you want to stop a rendering, you just push escape. And I'm going to convert this to a much smaller resolution so that it goes a little faster. You can see we no longer are calculating diffuse bounces, right? It's either in direct sunlight or it's not in direct sunlight. And that's not a very realistic representation of the project, right? It might be something that you could do in a very creative way to create a diagram or something like that, or to do a series of light studies about where solar direct sunlight's coming into the project. But that is what global illumination covers, right? That's what it controls. And so at the default, it says skylight illumination from IBL, which is a default kind of way of calculating diffuse light. But what we want to do is convert that to final gather. And final gather is an embedded calculation process in 3ds Max that defines how many diffuse bounces of light there are. So underneath that, we have settings for final gathering. And at the most basic level, you can kind of turn this tab left and right from draft to very high quality. Obviously, the higher the quality, the longer the rendering is going to take. In my experience, I've never had to go over medium. The only reason I would ever go up to high or very high is if you need an exceedingly accurate diffuse lighting system or representation. You should never really have to go over medium for the purposes of what we'll be doing. Because by the time you are at a high enough quality where you're doing high and very high, you should have knowledge over these actual adjustments to do them yourself. So for the purposes of this tutorial, I'm going to leave it at draft the whole time so that the calculations go a little bit faster. But it basically increases, rays per figure ground point. And I'm not going to discuss what these actually mean. If you're interested, you can always look them up. Under that is advanced, so you can do noise filtering, speckle reduction. Default is standard. Here's one instance where I would actually put this up to very high or extremely high. We won't do it today, but like when you know the rendering is where you want it, then you crank that up, okay? Because it's going to take a long time for it to actually reduce all the speckling in the project. Under that you have what's called caustics and photon mapping. Caustics covers what light does or how light acts when it goes through transparent or translucent materials. So if you have a thick transparent object that's actually refracting light through it or bending light, it won't, 3ds Max will consider that only if caustics is enabled, right? So for the most part, that's a relatively advanced technique. It's not something you'll really deal with a whole lot in your basic renderings. So I usually leave that unchecked, and even if you check it, if we render it, it'll give you a prompt that says there are no caustic photon generators in the scene, so it won't make any difference anyways. Under that is photon mapping, which is part of global illumination. What this does is it allows you to define how materials actually define the light. So if this is left off, 3ds Max will provide a kind of global way of dealing with diffuse bounces. If it's on, then each material defines its reflectivity, or you can specifically define its reflectivity or color bleed. So like a really colored surface, you'll be able to control how much color that actually bleeds. I don't usually use this unless you're really into high quality materials. And then there's a whole a bunch of other series of things that are underneath that. But what we're really going to deal with global illumination is final gather, precision and quality. Okay, so that's a kind of basic introduction to the render setup. The last thing we're going to talk about today is the environment window, and what that environment and exposure window. And what this allows us to do is it basically says this defines the camera. How the camera actually reacts to light in the scene. So before, in the render setup, you're telling how the renderer should define diffuse bounces, things like that. Here we're going to say this is how the camera should actually define that. And again, that's up in the rendering tab, and it's both exposure control and environment. This is the same window. I don't know why they have two selections. So if I click environment, you'll see this comes up. If I click exposure control, it's the same window. And that is a shortcut number 8, which comes up. So this allows us to actually define what is the environment that's in the scene. If we have a background environment map, it allows us to specify that. And it allows us to define the exposure of the scene. So up at the top, you have the background. And right now, remember when we made that daylight system, it asked us if we wanted to make an MR environmental or physical sky. That MR physical sky is this kind of cheesy, blue sky. The only thing that's really nice about this is that it's actually colored for the time of day. So in the evening, the sky will turn like a kind of purpley red, and that purpley red will actually impact the color of the shadows on your model. So maybe we can do that really fast. So right now we have this kind of blue, and that blue is basically the color transferring from the sky. So the light in the shadow is defined by the skylight. It's not defined by the sun. If we select our daylight system and we go to modify, if we change the time to, I don't know, let's say 1800 hours, hopefully it hasn't set by then, and we re-render it, okay, the sun has set. So we have to go back a little bit. You can start to see that the color of the sun, the color of the shadows, they actually start to get a little, not only, oh, you guys can't see that at all. Not only do they get a little darker, but they also get a little warmer, right? And it's the same thing will happen in the morning, although it's a little more yellow in the morning. So what it's trying to do is it's trying to kind of abbreviate the color quality from the sky during different times of the day. So we'll just leave that now. So I kind of, it's kind of useful in some cases, but really what we, I don't really like it all that much because it kind of looks like crap, right? And you can always Photoshop that out, I know, but there's kind of better ways to do that. And we'll talk about that on Thursday. But what we want to do is cover, again, the environment and effects. So here is that map. If I turn that off, if I deselect that, so we're not using that map anymore, if I re-render it again, you can see the map is gone, right? So whatever you have in here, whether it's MR physical sky or it's an actual image, like a bitmap image of a sky or background, that is controlled by the environment and effects window, okay? Under that you have global lighting, which is only really active when you have global illumination. And then you have the exposure control, and there's a variety of settings here too. So right now we have the MR photographic exposure control, which allows us to, and here's the rollout, right underneath that is the rollout. It allows us to say, we can define it by an exposure value, but it also allows us to do photographic exposures. So if you're familiar with photography, for instance, the time that the film is actually exposed to light, if you increase that, then more light hits the film and it gets brighter. So what that translates down to with their very simple kind of system is that the lower you set this setting, the longer the exposure. So let's get into a view where we can actually see that. So right now, as it's set at 15, which is kind of the standard for outdoor daylight systems, you can see it's a little whitewashed, mostly because all our materials are white too. But that might be useful. But if we change the exposure value way down, let's say we change it to 7, and we re-render, you can see that the entire image is whitewashed, right? There's so much light coming into the camera, it's so overexposed that you can't actually define any surfaces. Whereas if we go too high, I think there's a maximum to this. Yeah, the maximum is 16. Is that right? Yeah. It might be underexposed. Sorry. Or a little too dark. It's not so much a case for exterior daylights because the sun is so intense that you really need to have a very low exposure. But if you're doing interior renderings or relatively dark renderings, so if we go into later in the day, you can see that the exposure is quite dark, but if I just increase the exposure again and re-render, it's like it's the middle of the day, right? So part of what you control in terms of exposure can be the camera settings, which again is controlled in the environment and effects window. But as we'll show on Thursday, you can also increase or decrease the intensity of the light system. Under that, if you're very familiar with images, you can also control the highlights and burn, midtones and shadows. This can alternatively be done in Photoshop. You can do the same thing. But this basically adjusts the output of the final image. You can adjust the gamma, which I always usually leave at 2.2. And you can also add effects. And we'll add one effect on Thursday, which allows us, it's called volume light, which will allow us to see rays of light in an interior image in order to give kind of three-dimensional qualities to the space. But there's a variety of effects you can do, from fog to volume fog, so on and so forth. You can also download other effects that you can add into your scene. All right, so that covers that. So in summary, what we've kind of done is we've learned how to import Rhino files in 3ds. We've covered basics of interface, how to create and modify objects, and we've inserted a daylight system and covered render settings. On Thursday, what we're going to do is we're going to delete that kind of all-in-one lighting system. We're going to separate it into parts and control each light, as well as apply materials to an interior rendering. And what we're going to get as an output, just so you guys believe that it's possible to do, is a series of renderings, right, which start to have very interesting kind of spatial qualities. And here you see this speckling. That's just because I had low speckle reduction on. You can obviously increase that, but it increases the time of the rendering. But here we have volumetric light. You can actually see the rays, right, coming into it. We've applied materials, and we've mapped those materials and changed the map, and that's what we'll cover on Thursday. Are there any questions about that at all? Yes?
In the beginning, when you import the OBJ file, but when you said you have like intricate forms in Rhino, does 3ds I guess recognize it when it's not matched in Rhino? Like when you do the mesh command in Rhino to match the shapes. Like let's say that you know if it's intricate or not, and you don't mesh it individually.
When you create an OBJ file, it automatically meshes the object because that's really the only way 3ds Max will understand it. So you can't, it's not like you can import those objects as solids into 3ds Max. It will only understand it as a series of meshed surfaces. So as you convert it to an OBJ file, it's automatically going to convert it into a mesh for you. If you have a complex form, sometimes it doesn't always work out, right? You might see those tessellations in the curved surface if it's a complex curved form, and you might not like that. So the best way to do that is to actually create the mesh in Rhino, because then you'll be able to control the number of polygons, for instance. And then what you do is you select that mesh, and you can export that mesh as an OBJ file again, but you'll have more control over how many polygons it has. Does that make sense? Does that answer your question? Okay. But yeah, there's no opportunity to like bring in a solid geometry from Rhino into 3ds, unfortunately. Okay. Thank you. I'll see you guys Thursday. So let's see. Stop? Yep.